Okay, so here is the second unit, 2.1, derivative of a polynomial function. Derivative of a polynomial function, we apply a rule. What is the rule? If you have f of x equal to x to the power of n is a whole number 1, 2, 3, or any fraction 1 over 2, 1 over 3 is a number, right? It's the power of the x. So the derivative of that, the rule is bringing the power in front and power minus 1. Okay? I'm going to give you an example. Let's say f of x is equal to x to the power of 4. Then the derivative of this going to be power in front, 4, power is 4, and power minus 1. So 4 minus 1 is 3. If, for example, you have f of x equal to 5x to the power of 4, what do we do? The constant, you need to keep the constant. I'm going to keep the constant, then I would say the same thing. Power in front, so it's multiplied by 4, x to the power minus 1, 3. And I simplify, this is going to be 20 x to the power of 3. Okay, so I'm going to erase that. As you see, these are the rules. If you have a constant, you keep the constant. Okay, how about if you add two things adding together, what's going to happen? When two functions is adding together, the derivative of whole thing is going to be the derivative of individual. Let's say your h of x is 3x power 2 plus x power 4. So you want to take a derivative, you have to take a derivative of individual, right? So power in front, power minus 1, 2 minus 1 is 1, plus power in front, 4, x to the power of 3. Then you can simplify the next step. 6x plus 4x power 3. Same way, if between the function is minus, you just take individual function. Here it has a typo here, should be minus between them. Okay, see, we have an examples we do here. Let's say I want to do y is equal to the square root of root 3 of x. First, you have to write this one as a power. I know root 3 is like power 1 over 3. Then I apply the rule. Power in front, the power is 1 over 3, right? And then power minus 1, 1 over 3 minus 1. 1 over 3 x, so 1 over 3 minus 3 over 3, 1 minus 3 is 2, is negative 2 over 3. Then the power negative, you want to make it positive, it's coming into denominator. It's going to be x to the power of 2 over 3. Just flip it over, bring it to denominator. You can put it as a root 3. So here is root 3 x to the power of 2. We call it power rules. The same thing when you have y is equal to 1 over x. You can, the power of the x here is 1. So you bring this one up, the power become negative, right? Then you apply the power rule. The y prime is power in front, power minus 1. Negative 1 minus 1 is negative 2. Then you can flip it over, so you have negative 1 in numerator. You bring the x in denominator to make your power positive. So here is another example. Again, to take a derivative, you take a derivative of each term. So I keep the constant, power in front, It's going to be 6 power minus 1. 6 minus 1 is 5. Minus 4 is constant. So then power in front, power minus 1. 3 minus 1 is 2. And now what is the derivative of constant? Derivative of constant is 0. I'm going to elaborate around that, but just simplify that. So 30x power 4, x power 5, sorry, minus 12x power 2. This is the answer. Okay, let's just explore. Let's say you have y is equal to 6, right? I want to see what is the derivative of that. Graphically, you know y equal to 6 is a horizontal line. So this is the y equal to 6. You know the definition of the derivative, right? The definition of the derivative is the slope of the line. What is the slope of the line? Of course, 0. That's why the derivative gonna be 0, because the slope of the line is always 0. Another way that you could do is just the rule. Here, y equal to 6 is your function. But what is the power of the x here? The power of the x is 0, because x to the power of 0 is 1. So basically 6 to the power 6 multiplied by x power 0 is the same as 6. So if you apply the rule, which is saying power in front, power is 0, and power minus 1, right? So 0 multiplied by any number, anything is 0. So prove that looking graphically, algebraically, I prove that the y prime is 0. If the y is constant, if your function is constant. Here is another example. So since this is mixed, it's negative 3x power 5 plus 8 square root of x minus 9.3. Since the square root, I need to write it as a power. So a square root is a square root, I put x to the power 1 over 2. Then I apply the power rule. For this one, power in front, negative 3 multiplied by 5. And power minus 1, 5 minus 1 plus 8. Power in front, 1 over 2 is going to be in front, and the power minus 1. And the derivative of a constant, we proved that is 0. So negative 3 multiplied by 5, negative 15. So 5 minus 1 is 4, plus 8 multiplied by 1 over 2 is 4. X to the power of 1 over 2 minus 1 is negative 1 over 2. I can flip this one over, bring it in denominator, and write it as x power 1 over 2. And you know, x power 1 over 2 is the square root of x. Okay, next example, when you have two things is multiplied by each other, you can expand it or you can use a product rule. Product rule is coming in the next topic, but right now, you don't know that, you have to expand it. So how to expand it? The first number multiplied by that, this one multiplied by that, and then negative 3 multiplied by x, negative 3 multiplied by 1. So 2x multiplied by x is 2x2. 2x multiplied by 1 is 2x. Negative 3 multiplied by x is negative 3x. Negative 2 multiplied by 1 is negative 3. So these two you're adding are the same term, so it's negative x. So the overall is 2x power 2 minus x minus 3. Then you simply take a derivative. Derivative that is power in front, power minus 1. Here is the same thing, power in front. Power of that is 1, right? You bring it in front, x to the power of 1 minus 1, right? So 1 minus 1 is 0. So x to the power of 0 is 1. Basically here the answer is just negative 1. So it's 4x minus 1. Just remember, any linear function that you have, let's say y is equal to 7x. If you say what is the derivative, simply you don't have to think about power rule because the slope of this function is 7. This is a line. Remember that y is equal to mx plus b. The coefficient of the x is a slope. If you have a line, a linear, so simply that. For that one, we had negative x, right? Simply it could that the y prime is negative 1. The coefficient of the x here is negative. Here's another example. Determine an equation for the tangent to the curve at x equal to -1. So this is your curve, right? And I want to find the equation of the tangent line at the point x equal to -1. To have this equation, you know the equation of the line is mx plus b. You need to have a slope. A slope of tangent line is a derivative of this. If you want to take a derivative of that, it's power in front, power minus 1. Same things, power in front 3 multiplied by 2x. The derivative of 5 is 0, right? So formula of 3 is 12x power 2 plus 6x. So that's the derivative. If you want to find the slope, you know derivative means a slope. At -1, you just, so this is f prime x, right? This is f prime x. You just simply find f of prime of -1 will give you the slope at -1. Simply instead of the x here, I put 12 multiplied by -1 power 2 plus 6 multiplied by -1. If we do this calculation, the answer will be 6. Right, so I have a slope, which is 6. So it's y equal to 6x plus b. Now, how do I know the b? I need to have a point. It's good that I have a point here. I know the x of that. How do I find it? Y? I just put it there. F of x at -1. -1 power 3 plus 3 multiplied by -1 power 2 minus 5. So here you'll have -4 plus 3 minus 5. So it's -1, it's going to be -6. So the point here is -1, -6. What I do, I take this, and instead of the y, I put -6, instead of x, I put -1. So -6 equal to 6 multiplied by -1 plus b. So basically b is equal to 0. So you write your equation 6x plus b, which is 0. The answer is that. Okay, so here's another question we do. A flaming arrow is shot into the air modeled by this function. Determine the height of the arrow at 2 seconds. So the function is the height versus time. If the time is given, you can find the height. To find the height at 2 seconds, just simply instead of the t everywhere, you put 2, as we did here. And the answer is 31.4. The next question said determine the rate of change of the height of the arrow at 1 second, 2 seconds, 4 seconds, and so on. Rate of change is the slope. The slope is derivative. What you do, you just take a derivative of that. Take a derivative of this, you need to apply the power rule, right? Here is -4.9, power in front, power minus 2, so it's t, plus, this is a line, just simply the slope of that is 24.5, and the derivative of 2 is the constant, derivative of constant is 0. So that is my derivative, right? Just 2 multiplied by 4.9 is going to be -9.8 plus. So that was the derivative. At the first second, just simply instead of the time, you put 1 and you calculate the height, the rate of change. At 2 seconds, instead of the time, you put 2 seconds and calculate, you find the rate of change. And so on for 4 seconds and 5 seconds. As you see, here the rate of change is positive, here is positive, but here is negative. When your arrow going up, the slope is positive. When your arrow go down, the slope is negative. There is one more question here. Determine the coordinate of a point on a graph f of x equal to x power 3 plus 3, x power 3 plus 3x, where the slope of the tangent is 7. Okay, a slope is derivative, means the derivative should be 7. So what I do, you just take a derivative of that power in front, power minus 1, and derivative of 3x is 3. I need to equal that. This is my the derivative. I need to equal to 7, and then we solve for x. So doing so, you can factor out 3, divide both sides by 3, 7 divided by 3, and bring the 1 to the other side. It's 4 over 3. The square root of both sides. So square root of both sides, but make sure when you do square root of both sides, you have to put plus, minus. And you know a square root of 4 is 2, and instead of a square root of 3 in denominator, here is plus, minus. That is your x. But since this coordinate means you need to have x and y. To find y, simply instead of the x, you put your value of the x, which is 2 over 3. So here is x power 3 plus 3x. Instead of the x, you put 2 over square root of 3. And here is instead of x, you put 2 over square root of 3. So you simplify that, and that's going to be the answer. The same thing, you have another x, which is negative 2 over square root of 3. Instead of x again, you put that number, you simplify. And that would be the y value. So you have x and value. And there is 2 points, as you see. So there is a worksheet. So for the worksheet, you can do question number 1, 2, 3. Question number 5, 8. Question 11, 12, 14. That would be enough for this worksheet.